Hi everyone, welcome back to Requirements Engineering. Grab a glass of water, settle in. Today we'll talk some more about goals and constraints. So, we already spoke about why we need goals. Goals are important to make the direction clear of where we're heading in systems development, to make sure that our stakeholders align in what they want. And we've talked about the definitions, that goals are statements of intent, and that they usually describe some characteristics that the future system should fulfill or some direction that we wish the business surrounding the system should head into, or they can be constraints. Today we'll dive a little deeper into what types of goals there are, into refinement and abstraction, and into how we can use goal models for analysis and quality assurance, as well as a couple of other techniques for goal modeling. So, for a start, what types of goal models do we have out there? We have goals as networks of characteristics. So, they can simply be a set of related characteristics. We can depict that in a loosely connected graph. Then we can depict them in a tree. And so the tree has the advantage over the network that we have one clear starting point up here, a root node. And then from there, we can decompose and refine and look into more details. So we have also, as in a network, a set of related characteristics of goals. And in addition, they have a hierarchical refinement relation. And on same levels, they have interdependencies. We do have a couple of techniques that help us model goal trees. Some of those are KAOS. KAOS is short for Keep All Objectives Satisfied, and this was developed by Axel van Lamsweerde and colleagues. And then we have GSN, which is short for the Goal Structuring Notation by Kelly et al. And we have I-star modeling, according to Eric Yu and colleagues. Now, when we look at the expectations that goal models create, then we can read them from the bottom up. So the leaf of a goal tree can exclusively be related to its context with regard to its satisfaction. So I look at the leaf, at what the leaf says, only in regard to the context of where it came from in that tree. And looking at requirements, I know that the leaf of a goal tree can be related to the system with regard to its satisfaction, and that I can deduct both functional and non-functional characteristics of the system. The expectations as well as the requirements can be combined into assumption guarantee pairs. So assumption guarantee specification is something we may want to use in formal verification if we have to verify that our system considers certain constraints. And we can make those assumption guarantee pairs with regard to the interface between system and context. So if I assume I get correct numbers as input, then I can guarantee that my calculation is going to be precise. That would be a little example for an assumption guarantee pair. Now we have different types of goals. We characterize goals according to what underlying system are they referring to? Are they referring to a system model? Are they referring to a quality model? Or we can differentiate them according to the application domain, according to the characteristics of the expected system context. For example, in an embedded system domain, that would differ from a business information system context. And we can differentiate the methodical approach, for example, KAOS, Keep All Objectives Satisfied, as well as specific characteristics that can be expressed by the modeling concepts that that technique allows me to use. And on the right-hand side, you see a couple of examples for high-level goals. For example, reduce production costs or expand market. Those are business goals, high-level business goals that then need to be broken down to understand, hey, what does that mean in the context of the system that I'm developing? How do I need to understand that to be able to design that into the system? And then we have the green goals, automate generation of finance reports or increase process efficiency. Those are related to the functionality of the system, which means that I have to then think about how can I design that into the system to make sure that I live up to that. And then the blue ones are quality goals. So they're on the level of system goals. Increase performance, increase maintainability, increase security. Those are all quality attributes that I need to make sure I can actually guarantee that I build them into the system in this way. Now, if we take the example types for goals according to Lamsweerde, remember he is the guy who invented KAOS, keep all objectives satisfied, then we see a slightly different classification. Remember, classifications are only used in requirements engineering to help us sort things more easily. So they try to provide us with a system that helps us deal with information. So there is no final answer to which framework is the best one. So I'm going to be presenting 3 frameworks in here. We have the framework of the previous slide with quality goals, business goals, and functional goals. And then we have the Andire framework that talks about business goals, usage goals, and system goals. Different category names for almost the same thing. And we have the ones by Lamsweerde here, where we have quality-related goals, which are part of non-functional goals. For example, usability, performance, security, accuracy. And an example would be for reliability, 99% of the uptime, the system reacts correctly to user queries. And then we have optimization goals, which are also known as soft goals. So if they are measurable, they talk about maximization or minimization of something. Maximize efficiency, minimize costs, increases and decreases of something. An example for that would be performance. The operating rate of the tracks between A and B is increased by 3% per year in the next 5 years. Okay. Then we have behavioral goals, also known as hard or functional goals. For example, after the interaction phase, we can have a satisfaction goal where A requests from B, and we can have an information goal where A informs B. For example, for accuracy, 280 to 300 milliseconds, the train control must be informed about the state of the level crossing. So we have an information goal and we have a satisfaction goal. So we have the satisfaction in terms of within that given time frame that must happen, and we have the information goal. Train control must be informed about what? About the state of the level crossing. And then finally we have anti-goals, also known as obstacles. These could be, for example, safety hazard or security threats. An example here would be the data loss is estimated at 5% despite backup. Not what we want, but we know that that is an obstacle that we need to take into account. Now, I would like you to just take a minute and think about examples for each of the following types. Think about a car sharing system. We've used that example in the past. Just do that in your head really quick. What are 2 quality-related goals that you can think of for a car sharing system? Availability, reliability, accuracy, billing, lots of things to think about. Or then think about optimization goals, soft goals. What are things that you want to maximize? What are things you want to minimize in that system? Third, think about behavioral goals, also known as hard or functional goals. So what are the things you want the system to accomplish for the user or to support the user in? And then finally, what are anti-goals? What are obstacles for the car sharing system? Just a little exercise to get your creative juices flowing. I'll wait for you on the next slide. Here we are. So now you have an overview over a couple of classifications for different types of goals. Now, let's look into refinement and abstraction. What do we need them for? Why are they useful concepts? We know that ideally, top-down requirements engineering would happen in a form that, based on an elicited and consolidated, general formulated set of goals, like the product must be deployable internationally, we would then in a next step define abstract requirements that are consolidated and documented. For example, the product must be deployable in third world countries. The product must be usable independent of the energy resource. Those could be two requirements that we derive from the abstract goal above. From those again, we then retrieve refined concrete requirements. The system has a dynamo that generates the necessary energy. The electric tension is at whatever it needs to be. Big surprise. Independent of the energy resource, yeah, that can mean that we just have to move our legs to get that system going. And then finally, we would determine a system specification. So we use a dynamo of the company AB. But we also know from the past weeks that RE does not always happen in a top-down form. In our ideal world, we have this one customer that we talk to and they instill all of their wisdom on us and then we can just work from there. But in practice, we learn a lot of things along the way. We have to talk to many people and we have to kind of weave the information together that we receive from them. We have to consolidate. We have to make sure that we resolve conflicts in there, that we find the trade-offs. And therefore, we also need to think about the part where we go reverse. Maybe we even have a previous system specification that we need to derive the constraints from, that we need to reverse engineer some of the constraints from. And then we go back towards the goals and see which of those goals need to be adapted. Are we still on the right track? And for that, we use the concepts of refinement and abstraction. So refinement means we drill down, add more detail. Abstraction means we look at the bigger picture. We remove details. So the abstract version, goals, they're often hard to measure. System must be deployable internationally. System must be easy to use. The development will follow a systematic process. What does that really mean? So we derive some more specific requirements. We add more detail. We refine. Now the objectives are measurable and decidable. The user interface must support the languages English, Spanish, German. Or the average inexperienced user must be able to use the function rent car within 20 seconds. It must be easy to use. Third, the process must be certified as CMMI level 3. That would certainly be one way to ensure that it's a systematic process. Now, if we do the round trip, the requirements make the satisfaction of the goals more concrete over various steps. And the goals are a justification for those more concrete requirements. What is also important is the tracing for those, because ideally the relation between goals, abstract and concrete requirements are documented in a traceable way. So if something changes at one end, I can propagate those changes through the specification in either way. So abstraction and refinement, defined. Abstraction means we ask what goals are behind the requirements, what might open up the design space. So this is taking a step back, looking at the bigger picture. Which goals are determining the currently present set of requirements? So what was the reason behind the current set of requirements? So it's always why questions. We try to retrieve application domain knowledge. In the level of abstraction, we go up. For goal refinement, in requirements decisions, so we take requirements engineering decisions, and in scoping, we ask for which tasks or functions of the system do we need requirements? So we try to detail, we drill down. For which context do we need to deduce requirements? And then the system scoping, how can the design space of the problem under consideration be technically determined? So for refinement, we always drill down. We always ask, how do we do something? For which part specifically? So keep those two in mind, because that's the way how we iterate through goal models. Now, how can we use goal models for analysis and for quality assurance? First of all, most importantly, we use them to detect goal conflicts. Low production costs, easy to use, high information security. Even if I did not put that picture in the background, we could gather that, yeah, there is a potential goal conflict. So we will have to find a middle ground. Maybe you remember the triangle of cost, quality, and time, development time, where the consultant said, pick two. So cost, quality, time, you will only ever be able to optimize for two of them if you give in for the third one. Or you try to find the perfect balance here in the middle, but perfect balance is a tough thing to achieve, so usually the trade-offs will have to be made individually. Now, to resolve goal conflicts, we will first try to make goals measurable by evaluation and by prioritization. That's how we make them comparable to each other. And then for a goal, specific threshold levels are determined as standards that can be reached. Then we prioritize the goals, and then we have to resolve them by negotiation. So first, make them measurable, give them a priority, and then resolve by negotiation. There are models out there like, for example, the Easy Win-Win model by Barry Beam that can help as negotiation tactics. And Barry Beam derived this more specifically for requirements engineering, but it came out of the Harvard Win-Win negotiations method. So even if you just look up the original Harvard Win-Win negotiation tactic, then you're already well on your way. Now, I talked a few times about KAOS, keep all objectives satisfied. And this technique allows us really nicely to look at goal conflicts. So we see here a local train, and it has two top-level goals. One is serve more passengers, and the other one is minimize costs. Those two are potentially in conflict to each other. Why is that? If we break both of them down, then we see that to minimize the overall costs, we need to minimize the development costs. But to serve more passengers, we need to add new tracks, and that counterindicates minimizing the development costs. So this technique makes it very obvious and very easy to explain visually to a stakeholder where conflicts lie. Yes, it may not always be as obvious as serve more, minimize costs, but this example shows you that the technique is designed to help it make conflicts very obvious. Now, last but not least, a couple of techniques for goal modeling. I mentioned keep all objectives satisfied, and then there's also the I-STAR modeling framework, Eric Yu et al. And then we can use system dynamics and balanced scorecards for encompassing analysis and simulation of complex dynamic systems. Balanced scorecards come from the area of business analysis. So here we venture off again into the area of business analysis, which is a good thing because they are our number one source of information. And then some of the basic ideas and commonalities of goal modeling techniques are that we have usually the possibility to hierarchically decompose goal into subgoals. We can model dependencies, for example, conflicts, but also supporting relationships. We can map goals to agents or stakeholders. So those agents can be subsystems, that can be components, they can be actors, or more high-level stakeholders. And goal modeling techniques allow us a seamless transition to design because they provide a structured way of breaking down information and refining information that will eventually feed into the design. So here again, a KAOS example. In a little more detail, how we use that notation is you start with the soft goals, which are denoted by a fluffy cloud. Soft, fluffy, yep. And you can model an abstract solution alternative via an OR, and you can model a goal satisfaction via AND combination. So we can say, if we want to serve more passengers, we can either add new tracks or we can maximize the train speed and minimize the distance between trains. Both of those are valuable solutions or feasible solutions. And if we want to minimize the costs, then we have to minimize the development costs and also minimize operation costs. And if you remember the refinement and abstraction, if you want to go one level up, you ask why. Minimize development costs. Why? Because we want to minimize costs overall. And if you ask how, you go one level down. How can I minimize costs? By minimizing development costs or minimizing operational costs. We also have the opportunity to show positive and negative contributions, denoted by pluses and minuses. So we know that maximizing train speed and minimizing distance between trains will contribute to serving more passengers. And new tracks added will subtract or take away from minimizing development costs. We have, like I said on the slide before, the fluffy clouds denoting the software optimization goals, and the rectangular goals at the bottom, they are behavioral goals. So that's where we become really concrete, where we essentially take early design decisions on how this is going to be implemented. So we can measure the goal satisfaction by evaluating how well sub-goals and hard goals that implement your soft goals are implemented. And then we prioritize, and when we take the measurable requirements that we've broken our soft goals down into at the bottom and then add up what they bring in terms of goal satisfaction, then we get back to the overall evaluation of goals. The other technique that is very much in use out in academia, but also to a certain extent in practice, is I-STAR. The difference of I-STAR is they focus more on modeling goals according to which actor they came from. So you see here a meeting scheduler, and the dashed lines give an actor boundary, which means this is the area that one certain stakeholder is concerned about. So on the right-hand side, we see a meeting participant who has an actor boundary around a bunch of goals, from participate in meeting to finding an agreeable meeting to agreeing on a date. So depending on whether it's more important for you to be able to model constraints and the trade-off between constraints, which would point towards chaos, or whether it's more important to you to differentiate the information sources that your goals came from, that would point more towards I-STAR. This is one way how to choose your modeling technique. Finally, the references for this one. Axel von Lamsweerde wrote a pretty solid book on requirements engineering, where he describes how you get from system goals to UML models to software specifications, and he uses the KAOS technique in there. And on the other hand, Eric Yu proposes agent-oriented requirements engineering and describes the I-STAR modeling technique in first this paper from 1997, and then a lot of follow-up papers and more detailed research later on. Thank you so much. I will see you next time. Go model some goals.